Lesson 5.2, Congruent Polygons. Essential question, can I identify and use corresponding parts of congruent polygons? Can I use the third angles theorem? In our study of the four transformations, we found that 3 of them are rigid. And these 3 will help us show that one triangle is congruent to another. Let's describe a composition of rigid motions that map triangle ABC to triangle DEF. So if we can describe this rigid motion, we know that these triangles are congruent, and that comes from the definition. Congruent triangles if and only if there is a sequence of rigid motions. What it looks like I'm going to need to do is it looks like I'm going to need to match A with D, and in order to do that I think I'm going to have to reflect over the x-axis. So A is going to get reflected. This will be A prime, and then C will get reflected over here. The B's on the x-axis, so it'll stay put. Now once I see this, I can see I just need a translation to get A to go to D, C to go to F, and B to go to E. Let's stop the screencast and see if you can write the rules and then do part B. Now here are the answers. I went ahead and actually drew the reflection a little better, and here is the reflection rule, and then here's the translation rule. And this one just needed one rule. It was the 180-degree rotation. All right, so one more time. 2 geometric figures are congruent if and only if a rigid motion or a composition of rigid motions map one figure onto another. When this wonderful mapping takes place, you're going to find that all the angles, corresponding angles match, and all the corresponding sides match. What we refer to as corresponding part are these angles and these sides. So this matching is going to take place. We don't actually do the rigid motion, but we know when it happens, this idea of matching angles and matching sides takes place. And these are going to be the corresponding angles, and these will be the corresponding sides. All right, one more time. 2 figures are congruent. This is congruent, a figure is congruent to another figure if we can see the composition of rigid motion. Let's go through this process. To show that this triangle is congruent to this one, I am first going to go to a translation to force point A to match to point D, and that's what's happening right here. Now I'm going to do a rotation to force this side to map onto this side, and then I'm going to get this picture, and then I'm going to use a reflection to get B to match onto E, and we get this. So if we can get all 3 pairs of sides and all 3 pairs of angles to match, then we know rigid motion has taken place, and then we know we have congruent triangles. Before I leave this, I do want to talk about this right here. You can mix the letters up. We know that B has to go with E, but you don't have to just put it in the middle. If you want to put B in the front, it has to also, the E has to be in front also. C has to go with F, so just make sure whatever position C has in the 3 positions that F is in the same position. So you and your neighbor could have the same answer, but it will look different. All right, we want to write a congruent statement for the triangles. So I'm going to start off with triangle JKL. It doesn't matter how you start, it's how you finish. And what I'm going to do is I'm going to see J has the 2 tick marks, so it has to match with T that has 2 tick marks. K has 3 tick marks. I've got to match it with S that has 3, and then there's only 1 letter left, which is R. This is what we call the congruence statement. You see congruence of the 2 triangles. Identify all pairs of congruent corresponding parts. I'm not going to use the diagram anymore because this really tells me a lot. Angle J is going to be congruent to angle T, the first position. Angle K congruent to angle S. Angle L congruent to angle L. These are all my angle pairs. Now I'm going to go to my side pairs. JK, first 2 letters, congruent to TS, first 2 letters. Last 2 letters, KL, congruent to last 2 letters, RS. And then the first and the third, JL, congruent to the first and the third TR. And once you identify 3 pairs of angles and 3 pairs of sides, you've identified all the congruent corresponding parts. Okay, we would like to find the value of x, and this tells me a lot. This helps drive what I want equal to each other. Now, I see an x here with this side, 2x minus 4, and that's QR, and I'm going to go to my correspondence, and I can see that it matches with GF. So GF and QR are the same. QR is 2x minus 4, and FG is down here. It's equal to 12. So this is going to be 16 is equal to 2x, therefore x is equal to 8. Now I'm being asked to find y. Now y is occurring right here, and it is an angle, Q. And angle Q has to go with angle F. So the measure of angle Q has to equal the measure of angle F. And Q is 6y plus x, and F is right here, which is 68. Now remember, we just finished finding what x is, so I can go ahead and put 8 in here, which will help me find y. So 6y is 60, and therefore y is equal to 10. So the correspondence is what helps drive what sides and what angles are congruent to each other. Okay, I'd like you to try. Go ahead and use the correspondence to help you find 4 pairs of angles and 4 pairs of sides that are congruent, and then help you find x. Now here's the answer. All right, in the diagram at the left, we want to show that these 2 triangles are congruent. We're not going to show it with rigid motion. If we can show that 3 pairs of angles and 3 pairs of sides are all congruent, then we know rigid motion has taken place. So again, I want to show all pairs of angles. And so I'm just going to remind myself I need to show 3 pairs of angles, and I need to show 3 pairs of sides. Okay, so I need to show that angle P is congruent to angle angle R. Angle P congruent to angle R. Now let's see what's happening. Angle P and angle R. Well, I can see that's true because if 2 lines are parallel, alternate interior angles are congruent. And that's going to be true for S and Q. So angle S will be congruent to angle Q, and then this will be the same reason. Now angle T, but I can't call it angle T because there's lots of angle T's here, but I do want to show that this angle is congruent to this angle. So I'm going to have to use 3 letters, PTS, congruent to angle RTQ, and that's because vertical angles are congruent. I need to show that PT is congruent to RT, and that's just by the given because the tick marks were given to us. TS congruent to TQ, the answer is given, and PS congruent to RQ, and again that's given. So I've done my job. I've shown that all pairs of angles and all pairs of sides are congruent, therefore rigid motion did take place, and therefore they're congruent. All right, these are the properties of triangle congruence. A triangle is congruent to itself, it has a symmetric property, and it has a transitive property. Third angles theorem. If 2 angles of one triangle are congruent to 2 angles of another, then the third angles are congruent. Let's go and see if this makes sense to us. I know that these 3 angles in this triangle have to add up to 180, and I know these 3 angles have to add up to 180 when I add them up together, and since they both add up to 180 each, they must be equal to each other. Now I know that A and D are the same size, so I can subtract them. Angle B and angle E are the same size, so I can subtract them, and you can see that after the subtraction property is used, I do get these third angles to be equal to each other. All right, let's take a look at this problem. We are trying to find angle BDC. And there's a variety of ways to do it, and I'm going to do it twice to show you. First, what you could do for yourself is just write down the measures of as many angles as you can. So this is 30 degrees because of the tick marks. This is 45 degrees because of the tick marks. These two angles add up to 60, so that means this is 120. And if this is 120, this angle is 60 degrees. And if I can find this angle, that might be helpful. That is 105. And if I subtract from 180, this angle is 75. Now, I was being asked to find BDC. That's this angle I'm being asked to find. So that will be 30 plus 75, and that'll be 105. So here's one way to do it. Now I'm going to show you another way to do it. I'm going to use this triangle right here to help me, because this is the angle I want to find, BDC. And I know this is 30, so this is 30. This is 45, 45. Let me go ahead and draw the triangle outside without all the lines. This is what I found. I found that this angle is 30 and this angle is 45. So by the third angles theorem, again, 180, take away 75, this answer is 105. So I showed you a couple of ways to get these answers. There's not just one way. All right, let's use the information to prove the triangles are congruent. In order to prove the triangles are congruent, we have to have 3 pairs of corresponding sides, 3 pairs of congruent angles. Now already we have a pair of sides here and a pair of sides in the given. And so I just need another pair of sides, AC and AC. Well, that's reflexive. That side is congruent to itself. That's the third pair of sides. So I have 3 pairs of sides. Now I've got to look for some angles. In the given, they've already given me 2 pairs of angles. And so now I've got to show that this angle is congruent to this angle. And we can do that by the third angles theorem. And that will give us our third pair. So we have all 6 pairs. That means the triangles are congruent because all corresponding parts are congruent. When that happens, I know rigid motion took place. Rigid motion took place, therefore the triangles are congruent. Okay, we're going to use the diagram to find angle DCN. DCN. So we want to find this angle. And I'm going to use the third angles theorem. I know that this adds up to 143, and when I subtract from 180, that's going to be 37. So this angle is 37. This angle has to be 37. They are vertical angles. So this is 37 degrees. All right, now I want to find the additional information that's needed to conclude the triangles are congruent. Now, in order to prove triangles congruent, I need to have all 3 angles congruent and all 3 sides congruent. So we know that angle D is congruent to angle S. We know that angle D and C is congruent to angle R and S. These are these vertical angles. And we know the third angles theorem will tell us that angle C is congruent to angle R. So we have all of these angles. We do have a pair of sides, which is CN congruent to NR. So this is all we have. We had some of this, we figured out some of it, and this is all we have so far. So what do we need? Well, we need 2 pairs of sides here. So that's the additional information that's needed. We need to make sure that, so we already have this part right here. We need to show that ND is congruent to NS, and we need to show that DC is congruent to SR. So they just wanted what was needed. They're not going to make us prove it. That's all we need. And this is the end of the screencast.